Well, hey, let's talk a little bit about simplifying radicals. Okay, so what you have probably done is hopefully you've printed off all these things and you've worked through them and you're checking your answers and you're coming back kind of looking to see what some of your misconceptions are. So let's go ahead and get started with number one. The square root of 75 is actually made up of square root of 25 times square root of 3. And square root of 25 is 5, and square root of 3 is going to stay 3 because I'm looking for perfect squares that I can go ahead and like factor out. Negative 6 times the square root of 100 is equal to negative 6 times square root of 100, which we know square root of 100 is 10, so times 10, so that equals negative 60. Again, I keep looking for perfect squares. Number 3 is a little bit different here because I have an x to the third, but I'm looking for the square root of that. And something I've been aware of is an x squared. A square root of x squared is x. It's the base number. So for instance, 3 squared is 9, but the square root of that is back down to 3. So the square root of 3 squared is itself. So any squares that I can find in these, any pairs, are going to equal itself. So I've got negative 5x times the square root of 2 times the square root of x squared times the square root of x. That's what all this really means because I'm looking for this pair right here. And that will simplify out and actually end up with a final answer of negative 5x. And I have an x times a second x, so that's going to be times x squared times whatever's left, which is 2x squared. So this is what's left and cannot be factored anymore. Let's see, number 4 here. This is actually equal to square root of 9n squared over square root of 36w squared. And I know that square root of 9 is 3, and I know the square root of n squared is n. Square root of 36 is 6, and the square root of w squared is w. Now I'm going to look and I'm going to notice that I've got these coefficients, and they simplify out. 3 over 6 is equal to 1 over 2. So I'm going to simplify those out to n over 2w. And that is my final answer. Let's try a few more. Oh, all right, number 5 here. I'm looking for common radicals, so I've got a square root of 2 and a square root of 2. I have no 5, so this can stay right, just like it is, 3 times the square root of 5. And I'm going to take this square root of 2, I have 11 of them, and the square root of 5, and I'm subtracting 5, so 11 minus 5 is going to give me 6. It's positive 6 times the square root of 2 is what I have left. Number 6 is a distribution one, so it's square root of 2 times the square root of 3. So that's what this looks like. Square root of 2 times the square root of 3. And then that's going to be plus the square root of 2 times the square root of 7. So that ends up equaling the square root of 6 plus the square root of 14. And now these are not common radicals, so I cannot bring them together, and I cannot factor the 6 anymore or the 14 anymore. At least with a perfect square, I can't. And that's what I'm looking for to help me out. Number 7 here, it's another distribution one. The square, so this is saying 3 equals 3 times the square root of 2 times 3 plus, okay, there's another one. I got my 2 here. The 2 is outside, it's a coefficient, times the square root of 10 times the 2. Now notice the square root's in here, so I'm only multiplying the square roots together. Okay, let me simplify this out. So this is 3 times the square root of 6 plus 2 times the square root of 20. Ooh, but that square root of 20 can be factored somewhere. The square root of 20 can be factored into square root of 4 times the square root of 5. And square root of 4 is 2. So I'm going to multiply that out too. So 3 times, okay, so 3 times the square root of 6 for my first part plus, I'm going to look at this second part, this whole bundle of what happened here. I took the 20 and turned it into these two. Square root of 4 is 2, so this is saying 2 times the square root of 2, which is 4 times the square root of 5. This is my final answer. I cannot simplify this anymore. I cannot combine those terms. Number 8 and 9 is saying square root of 10 over square root of x. I cannot have a radical in my denominator, so I'm going to multiply by the radical itself. And square root of x times square root of x will be x. And in my numerator, square root of 10 times square root of x is saying square root of 10x. And that's actually simplified. Some students will want to try to simplify the x over the x, but you cannot, because that up here, that's not x, that's square root of x. And this is x down here, so two different values. So I'm not going to simplify those anymore. The thing is actually done. This guy's square root of 18 over square root of x to the third. I'm not going to do anything to the x to the third, but I'm going to multiply everything by square root of x to the third. Square root of x to the third. So I'm always multiplying by what I see. Because square root of x to the third times square root of x to the third is x to the third. Up top, square root of 18 times x to the third is square root of 18x to the third. Now I can do some more to this. This 18, I can get a square root of 9 times the square root of 2 out of that. That 9 is going to be a 3. So it's 3 times the square root of 2, which is good. And this x to the third is made up of a pair. It's made up of an x to the squared times an x. So this x to the squared comes on out. It's x, and I'm left with 1 left over. And that's all over x to the third. And it might look like we're done, but there's an x in here and an x down below, so 1 in the numerator, 3 in the denominator. So these, this one can cancel out as well as one of them down here. So I'm left with 3 times square root of 2x over x to the second. It is my simplified form. Yep, I can't do anything else with that one. I've got these guys over here to kind of remind us a little bit about what these look like. I'm looking for pairs. So 6. Square root of 6 squared is 6. The square root of 4 squared, because 4 squared is 16, and the square root of that is back down to 4. This is b squared, so the square root of b squared is going to be b. The square root of b to the fourth is going to be b to the second, because there's 2 pairs in there. B to the fifth, the square root of b to the fifth is going to be there are 2 pairs in there, and there's 1 left over. So 2 pairs and an apple. And an apple. Oh my goodness, that's so crazy. All right, let's keep going here. Number 10. Okay, so this guy is actually saying 7 times 3 and 7 plus 4 times 3. That's what this is saying. So now I need to do some foiling. 7 times 7 is 49. And I've got, now I can only multiply the coefficients on these guys. That's what this is really saying, so make sure you only do that. That's plus 28 times the square root of 3. And then I'm going to go inside again, only multiplying the coefficients. And then I've got my last one, which is this guy. And I'm going to, again, multiply my coefficients. So it's 4 times 4, which is 16, times square root of 3 times square root of 3, which is square root of 9. Now I'm going to simplify all this. And I've got 49 plus, common radicals, so I can pull those together. So the 28 and the 28 give me 56 times the square root of 3 plus, this is 16 times 3, which is 48. Again, going to keep combining. So then 49 and 48 come together to 97 plus 56 times the square root of 3. Now remember, I'm only combining like radicals. That's what number 10 is suggesting we keep an eye on. All right, number 11. Let's see what's going on with number 11. This is like a number and its conjugate. Okay, I'm going to FOIL this out, but hopefully you'll start seeing patterns here that when they have the same numbers but the opposite value in the middle, there's some cool stuff that happens with that. Actually, the middle term cancels out. So 4 times 4 gets me to 16. Outside is going to be, I've got a 4 and a square root of 2, so it's minus 4 times the square root of 2. Inside, it's 4 times square root of 2, so it's a positive. And I've got a square root of 2 times a negative square root of 2, so it's negative square root of 4. If I simplify this guy out, I'm going to have a 16. This guy right here actually cancels each other out. Square root of 4 is 2, so 16 minus 2. I end up with 14 as my answer for number 11. Let's try number 12. Number 12, I'm going to factor this out. So negative square root of 3 times 2. I'm going to name them up with negative 2 because there's really a 1 here. So it's negative 2 times square root of 3 times that. So a negative times a negative will be positive. Square root of 3 times square root of 7, square root of 21. And it seems like I should be able to factor something out of 21, but I can't. So that one's done. Just a couple more. Okay, I've got radicals down here, so I'm going to use what I know about conjugates. So minus square root of 5. Square root of 5. All right. So inside here, square root of 3 times square root of 3 times square root of 3 is going to give me my 9. No, square root of 3 times square root of 3 is going to be square root of 9, which is 3. And then my middle terms cancel, because it's a conjugate. Square root of 5 times the negative square root of 5 is minus 5. So because it's square root of 25 is what I get. So it's going to be minus 5. I'll look at my numerator here. 5 times the square root of 3 minus 5 times the square root of 5. And it looks like I can't do anything to my numerator. And my denominator becomes 3 minus 5, so it's negative 2. And that is my final answer. Number 14, again, in order to cancel stuff out, I need to multiply by the conjugate, but the opposite one. And if I'm going to do it to my denominator, I must do it to the numerator. Now remember, this one, my middle terms will cancel out, so I'm going to do square root of 2 times square root of 2, which is square root of 4, which gives me 2. I'm going to do negative square root of 3 times the positive square root of 3, so it's negative square root of 9, which is 3. And I'm going to go right to my final answer, because 2 minus 3 is going to be negative 1. And now let's look at my top number here. 7 times square root of 5 times the square root of 2. So that's saying 7 times square root of 5 times 2 plus 7 times the square root of 5 times 3. So 7 times the square root of 10 plus 7 times the square root of 15. And I don't have any common radicals, so I have to leave it. That's all I can do. Next one. Ooh, conjugate practice. Good stuff. Again, same terms, opposites, so that means it's going to be 3 times 3, which is 9. Negative square root of 2 times square root of 2, it's going to be negative square root of 4. So this equals 9 minus 2, which is going to be 7. Now let's look at this guy. I've got square root of 10 times square root of 10, which is square root of 100, so that's going to give me 10. And then I've got square root of 5 times negative square root of 5, which is negative 25, which is going to be 5. And here, I kind of skipped a step. So that this ends up being square root of 100 minus square root of 25. That's where I'm getting that from. Do I have any more? Ooh, yummy. Got another one here. I'm going to multiply these. Either conjugate, so 3 minus square root of 2, 3 minus square root of 2. Let's see what I get. 3 times 3 is my 9. My middle term's going to cancel. Square root of 2 times negative square root of 2, so it's square root of 4, which is going to be 2. So 9, 8, 7, so it's going to be 7. And in my numerator, I'm going to go right to my final answer. 7 times the square root of 5 times 3. It's going to give me 21. Yeah, 21 times the square root of 5 minus 7 times the square root of 2. and I'm going to see can anything be canceled or combined. So square root of 5, square root of 2 can't. But I'm going to look at the 21, the 7, and the 7, and you know these can be simplified. So 21 over 7 becomes 3 times square root of 5. 7 over 7 becomes 1. And this becomes 1. So there is my final answer. 3 times square root of 5 minus square root of 2. Ta-da! Last one, I promise. Square root of 7 minus 2. Square root of 7 minus 2. Again, I'm doing everything I can to get those radicals out of there. Square root of 7 times square root of 7 is 40. Square root of 49, which is 7. 2 times negative 2 is going to be negative 4, which equals, let's see, go to the top, I got 6 times square root of 7 minus 12. Okay, I'm going to check on this guy. So 3, oh, that's a 3. So 3, 6 times the square root of 7 minus 12. Oh, and this can be simplified more between the 6, the 12, and the 3. So this becomes 2 times the square root of 7 minus 4. And that is my final answer. All right, awesome. That sounds really good. All right, I'm going to go use, oh, you know what I'm going to do? I'm going to go and I'm going to carve a bar of soap into a shape of a snake and chase your little sister around with it.